Now let's take a look at distance and time graphs. So this is a little bit different than what we were doing before, where we were given some data and we had to graph it, do a line of best fit, and then answer some questions. There's no data really for any of these types of graphs. So before we do go into what a typical question would look like, let's first fill in, there's kind of 5 different options that we could have here. We could, and this is all walking away from some sort of detector. I don't know what kind of detector it is, but maybe it detects your movement or something. So you can walk, as you can see, I'll just get the highlighter here. You can walk quickly away from a detector, or you could walk slowly away from a detector. And so what would that look like on a graph? So say you were a distance, I don't know, 5. We were maybe 5 feet away or something. What would it look like as time goes on, as time is going on, what would it look like to walk quickly away from the detector? And so, well, if you were 5, here you are, you're 5 feet away, and you were walking quickly away, you'd be walking further away, look something like that. As time goes on, you're walking away, and you're walking away pretty fast. As opposed to over here, you could be walking away. As time goes on, you could be slowly walking away. So hopefully you can see the difference between that walking quickly away. Here, you're walking quickly, so it's a very steep. And maybe we should write that down. If you're walking quickly away, that's going to be something that's usually very steep. Whereas if you're walking slowly away, okay, that's going to be, I don't know how to say not very steep. You could just say less steep. Okay, so that's oh, there we go. So you can walk slowly away from the detector. That's going quite slowly, less steep. Or you can go quickly away. Well, that's going to look very steep. Well, you could walk towards a detector. Um, so here we are, we're 5 feet away again. And if you're going to walk slowly towards a detector, you might go something like that. We're walking closer to, see now maybe we're 3 feet away from the detector. So you were slowly walking towards. So as time goes on to the right, you are slowly heading down towards the detector. And so this is slowly, again, it's less steep. Whereas if you were at 5 and you were going towards a detector, it might look something like that. Like really quickly, you just shot down, you're right there at the detector. Um, so that would be a couple of examples. As time goes on, you're like right here, you're right as maybe only a minute has gone by, and now you're there. Or here, maybe I don't know, 1, 2, 3, 4, 5, 6 minutes have gone by, you're still not even there. Well, what would it look like if time was going on and on and on, and you weren't walking at all? You were just stopped. So if you were here at 5 feet away from the detector, what would it look like to be stopped and you weren't getting further away and you're not getting closer, you're not getting further, you're not getting closer, you're not getting further, right? Like you're just there. Well, if you're at 5 feet, you're just gonna stay at 5 the whole time. So it's not less steep, and it's not very steep. It's got no steepness. There's no steepness or no slope. It's got nothing. So at the very beginning here, you're 5 feet away. Time goes on, 6 minutes later, you're still 5 feet away. So that's what we need to know when we're looking at all of these distance and time graphs. We need to know, what does it look like to go somewhere or get further away from something, to get closer to something, or to not go further or closer, just kind of stand still. So let's we'll do the next video. We'll look at this first example here, describe what's happening in each section. So we'll look at that in just a moment.